are discussing a very important point, that is, if a function is discontinuous, then how to check whether that function is increasing function or decreasing function. So how to check? So for that we have to remember these points. A discontinuous function is called increasing function if it is increasing in every continuous interval. Okay, so we should not compare the values of one interval to other interval. For example, this is x-axis, this is y-axis. So one graph we are taking. So this graph we are taking. Okay. So this function is what? Y equal to fx, and it is a discontinuous function. So we have to check whether it is increasing function or not. So it is discontinuous because this one and this one are two different graphs is there. Okay. So these two graphs are breaking. So this is discontinuous function. So for discontinuous function, what you have to check? In this interval we have to check separately, and in this interval we have to check separately. Okay, we should not compare the values of this interval to this interval. For example, at this point we are getting this value, and at this point we are getting this value. So we can say that this value is greater than this one. Okay, but for checking increasing or decreasing, we should not check this one and this one combined. We should check this one separately, and we should check this one separately. So a function is called increasing function if in this interval this function is increasing and in this function it is increasing, then we can say function is increasing function. So you can see if I increase the x value, y value is increasing. Similarly in this interval also, if I check, if you increase the x value, y value is what? Increasing. So this function is called increasing function. Okay, same definition for decreasing also there. Okay, a discontinuous function is called decreasing function if it is decreasing in every continuous interval, then function is called decreasing function. For example, this is x-axis, this is y-axis. So we are taking this one and this one. So here this interval we have to check separately, and this interval we have to check separately. So you can see in this interval, if I increase the x value, y value is what? Decreasing. And here also in this interval also, if it is decreasing, so we can say this function is what? Decreasing function. Next we are discussing non-monotonic function. What is non-monotonic function? A function is called non-monotonic if it is decreasing, as well as increasing in their domain, then that function is called non-monotonic function. And that function is called non-monotonic function. Okay, for example, y equal to sin x. So sin x graph, if you see, this graph will come like that. So you can see here it is increasing, then again decreasing, till here it is decreasing, then again it is increasing. So you can see here, till here it is increasing, then decreasing, till here it is decreasing, then increasing, then again it's starting decreasing. So this is what non-monotonic function. Next example is y equal to ax square plus bx plus c, where a should not be 0. A should not be 0. So this is quadratic equation, and this one graph we know, this one graph will come like that, graph will come. It will come like that. It depends on what? A value and discriminant. So you can say this one, till here it is decreasing, then increasing. So this is also called non-monotonic function. Okay. Next we are discussing interval of increasing and interval of decreasing. In short, we can write as what? This one we can write IOI, interval of increasing, and this one we can write interval of decreasing, IOD, interval of decreasing. So what is interval of increasing and what is interval of decreasing, that we are discussing now. So first we are discussing IOI, interval of increasing. Okay, for a function, interval of increasing is the interval where dy by dx is greater than or equal to 0. Okay, and if dy by dx equal to 0 in that interval, then points should be discrete. Point should be discrete. And how to check whether point is discrete or not? For example, at x equal to a, dy by dx equal to 0. At x equal to a, dy by dx equal to 0. Then find dy by dx at x equal to a plus h and dy by dx at x equal to a minus h. For these values, dy by dx at x equal to a plus h should be what? Greater than 0, and for this one also this should be greater than 0. Then we can say that this point is discrete point. Okay. Next we are discussing interval of decreasing, that is IOD. What is interval of decreasing? For a function, interval of decreasing is the interval where dy by dx is less than or equal to 0, and if dy by dx equal to 0 in that interval, then point should be discrete point. And how to check whether discrete point is there or not? So here x equal to a, suppose dy by dx equal to 0, then we have to find out dy by dx at x equal to a plus h and dy by dx at x equal to a minus h. Now here this should be negative and this also should be negative. Then we can say that interval is what? Interval of decreasing.